Show that the given differential equation is homogeneous and solve it. So my funda is go with expressing in terms of y prime is equal to f of y by x, and after that it would be easy to prove it homogeneous. So first thing is, okay, left hand side and right hand side things are okay. Then we'll just directly write it as dy by dx. So this would remain wherever it is. So this would be the numerator. Okay, yes. And that would be your denominator. Right? Reason being, y will be wherever it is. This is going to get transposed, while dx will get transposed on the other end. So think about it, it's not too hard. And then we have y getting divided, not divided. So let me write this entire expression first. Plus y sine y by x. As you can see, I'm writing the question directly in this form. So x divided by y sine y by x minus x cos of y by x. Right. So here I need to re-express in the form of y by x. So there is a x over here, there is a y over here, so on and so forth. So what we can do is take x common in the numerator, and here again x common. Okay, so let me show this. So this would be y by x. So y into x divided by, I'm taking x common, so the x will get eliminated over here, while over here it would be y by x into sine of y by x. While in the denominator we have an x already, and I'm taking x, so this would be y by x into sine of y by x. As a single term I need to divide with x, so that I'm doing. Over here x by x will get cancelled, cos of y by x. Okay, here I didn't write that x by x, so you can write it again, not an issue. Okay, right, so this becomes 1, this becomes 1, and this and this cancels, so we have y by x over here. So we're almost there. Next is checking homogeneity of the differential equation. So what will happen? So we need to substitute x is equal to lambda x and y is equal to lambda y. So this entire expression, let me kind of copy this. So dy by dx is equal to, so this would be lambda x, this won't be there, this won't be there. Actually I could have just written that. You know what, let me do that only. Okay, so we have dy by dx, so that will remain the same because we are multiplying with the constant, the same constant with both. So this would be delta y by delta x, and we have cos of delta y by delta x plus delta y by delta x into sine of delta y by delta x. Yeah, there's a lot of writing, I agree. Divided with, okay, I don't have space. Okay, divided with y by x. I think this is this is sine y by x. Okay, so this would be sine of lambda by lambda x. Again, here also lambda and a lambda minus cos of lambda y by lambda x. So lambda, all of this will get cancelled. And it's same as the original expression. So the given equation is homogeneous, right? Now, okay, let me write the entire thing. So next thing is what? We proved this part, then we need to substitute. So let's substitute v is equal to y by x, and from this we can tell that y is equal to v into x. And when we differentiate this with respect to x, as per the product rule, this would be dv by dx into x, actually not v, plus v into 1. And so when we substitute it over here, dv by dx into x plus v is equal to v cos v plus v sin v, entire expression divided with v sin v minus cos of v, right? Now we need to rearrange and solve using variable separable. So let's do that. So dv into x by dx is equal to, if I transpose v onto the right hand side, we need to take the LCM. So v, things will get cancelled. I'm opening up the brackets for that reason, divided by v sin v minus cos v. This step is not required, it's only for your understanding. Okay, so we can skip this step and directly do the next step, and that would be v cos of v plus v square sin v minus v square sin v plus v cos of v. This entire expression divided with the denominator, because we took the LCM, right? It has the common denominator. Now this two getting cancelled, that's good. So dv by dx into x is equal to 2v cos of v, entire expression divided with v sin v minus cos v. Okay, so we are almost there. All we have to do is a bit of rearrangement. Then we have, okay, this would be actually v sin v minus cos v divided by 2v cos v. This entire thing is dv is equal to dx by x. So next step would be to integrate both sides. And now we can use distributive property to write this as v sin v by 2v sin cos v minus, okay, into dv actually. And I can take 1 by 2 actually out. This also I could have taken 1 by 2 out. Anyways, I've written it. Let it be there. So now again I'm using distributive property, remember. 2 I already written. So v cos of ve into dv. Right guys? So this is equal to integration of dx by x. Right here, you have v and v that get cancelled, cos and cos will get cancelled. And this is nothing but 1 by 2 integration of tan of x, which is log of secant f. V minus 1 by 2, this is log of v. This would be log of x plus log of a constant. We can do that. Okay, further simplification involves, first thing is I'll multiply this entire thing with 2 so as to eliminate this 1 by 2. And we have log of secant v by v is equal to 2 log of x into c. Okay, again I multiplied this entire thing with 2. So the 2 went away, not go away, went away, and we have this to be basically log of secant v by v. Actually, this step is not required, it's only for your understanding. So log x square into c square, that I can write as c, capital C. So what did we use over here? Log of, yes, there's a lot of things that is happening. If you're not strong with your basics, it would be confusing. I use log property, n log of x is log of x whole to the power of n. And finally, taking exponent on both sides, we have secant v by v is equal to x square into c. And finally, substituting v is equal to y by x. This is secant y by x into x by y is equal to x square into c. So this and this will get cancelled. So we have, I don't know exactly how to express this. Let me take a second. So I'm just going to put this, guys. I mean, this is also, even this is okay. Let me just write the final answer in my own way. X into some constant c. You know, even this is good. You don't have to think too much about all of this. So yeah. Okay, so we have this as your answer. Okay, you can pause and have a look.